Hey guys, welcome to the last day or the last topic of this unit. You will have a review day. Your test is going to be Monday, so be watching out for that. We're going to do limiting reactant today. Tomorrow will be review, and Monday will be the test. All right, so limiting reactant is a really cool topic. It's basically figuring out in a reaction which reactant you're going to run out of first and how much you're going to have left over of the other one. And it also helps you determine how much product you can actually make. Now, the steps are listed up here in the notes, which should come from your digital notebook. You can read through them, but I'm just going to talk through them down here with the example problems as we normally do. So, limiting reactant problems are actually going to involve two-dimensional analysis charts, but they use all the same conversions that we've already been using, so there's no need to worry about adding conversions. But here for this first question, I'm actually going to use not chemistry, I'm going to use baking as the example, so you can kind of see what exactly we're talking about when we say limiting reactant. So the scenario is this. You want to make cookies, and you have 6 eggs, 18 cups of flour, and plenty of everything else you would need to make cookies. Which ingredient is in excess, which is limiting, and how many cookies can you make? All right, so what we're doing here is we're starting with 8 eggs, or not 8 eggs, that it says 6 eggs. We're starting with 6 eggs, 18 cups of flour, and plenty of everything else. So those are our two givens, like we would have in other questions, 6 eggs and 18 cups of flour. And two givens goes for the two different charts. So you're going to write your givens in the chart. We've got 6, sorry, I was using a green pen, need to make it black. 6 eggs and 18 cups of flour. That's what we've got. And our recipe says that 2 cups of flour plus 2 eggs and everything else makes 3 dozen cookies. So essentially our strategy that we're going to do here is we're going to take our 6 eggs and see how many cookies it will make, and our 18 cups of flour and see how many cookies that will make. And we're going to do that using the recipe. So just like we did with stoichiometry, we're going to look at our chemical equation, which here is the recipe. And it says if you have 2 eggs in the recipe, you can make that into 3 dozen cookies. That equals 3 dozen cookies, which is an equivalency that, or a conversion factor that we can plug in here to the chart. Just like we always do, whatever unit's on top goes on bottom next. So we'll put the 2 eggs part on bottom and the 3 dozen on top. We also know that 1 dozen equals 12. So we can say 1 dozen cookies equals 12 cookies. We plug that into the chart to get rid of dozens. 1 dozen cookies equals 12 cookies. And figuring out the number is multiplying on the top, dividing on the bottom, which is going to give you a final answer of 6 times 3 times 12 divided by 2, which I believe is, let's see, 108 cookies. That's how many cookies you could make with 6 eggs. But let's go see about our flour. We've got 18 cups of flour to start with. Let's see how many cookies that'll make. 18 cups of flour. So we need to look at flour in the chemical equation / recipe. And it says 2 cups of flour is going to make 3 dozen cookies. We're going to plug that in as our conversion factor. Cups of flour goes on the bottom. 2 cups flour becomes 3 dozen cookies. And we can change once again into regular cookies. 1 dozen cookies equals 12 cookies. So now we are in cookies instead of flour. Got to multiply on the top, divide on the bottom. This one will get you 324 cookies, which is a dang lot of cookies. All right, so let's consider the scenario once again. We're making cookies. We've got 6 eggs and 18 cups of flour. What we have discovered is that if you use 6 eggs, you can make 108 cookies. If you use 18 cups of flour, you can make 324 cookies. But you're using these things together. You're using both the eggs and the flour. So say you're baking along and you're using up your 6 eggs and you're using up your flour, and you get to 108 cookies. You've made 108 cookies. That means you have used up all of your eggs because you can't make any more cookies than that with your 6 eggs. So after you get to 108 cookies, you have to stop baking because now you don't have any more eggs. You just have flour left over, and you can't make cookies with just flour. So what this means is that the ingredient that limits you is the eggs. It's the one you run out of first. And the one that is in excess is going to be the one that you have left over. So that one is flour. And the amount that gets produced is the smaller number, because after you make 108 cookies, you're done. You can't make any more cookies. So your amount produced in the end is 108. That is cookies. So now we need to take this and apply it to some chemistry. And this question is going to be long, so bear with me while we do it. This question asks how many grams of SiO2 can be produced with 245.1 grams of Si2H3 and 152.8 grams of O2. And this is our lovely chemical equation, which we've been using for days in these notes. So let's go look at our two givens. We've got two reactants here, and both have given quantities in grams. We've got 245.1 grams of Si2H3, which we'll put in this top part. It doesn't matter which one's top and which one's bottom out of the two charts, but that's the one I'm doing up there. And on the bottom, we'll do 152.8 grams of O2. Those are the two reactants we're starting with. We're going to see which one we run out of first. And we're also going to see how many grams we can make total. All right, so right now, we've got grams of Si2H3. Way over on the other end, what we want to end up with is grams of SiO2. So I'm going to write that down here just so we can remember where we are headed. And both charts go to the same place. We're trying to figure out how many grams of SiO2 each thing makes so that we can compare. So now comes the tedious part. We got to do all these conversions. Let's start on the top chart. Right now we're at grams. If you are lickety-split with your conversions, you know that you can only go from grams to moles of the same substance. And that conversion uses the molar mass. So we're going to use molar mass to convert this 245.1 grams of Si2H3 into moles. And if you're looking at your list of conversion factors down here, that's going to be this one, moles to grams for Si2H3. And we got to fill that in over here on our little molar mass chart that is conveniently located for your usage. I will say that silicon is the first element, silicon, I guess, and hydrogen's the second. There's 2 silicons, 3 hydrogens. I don't actually have the average atomic mass of silicon memorized, so let me whip out my handy-dandy periodic table real quick. For some reason, every time I do that, it makes 2. And we'll go look at silicon. Silicon is 28.086. Let me hide that somewhere convenient. 28.086. And that's in grams. Hydrogen is 1.008 grams. Now I got to do some multiplication. 2 times 28.086 is 56.172 grams. And 3 times 1.008 is 3.024 grams. Add those two things up, you get 59.196 grams. So 1 mole of Si2H3 equals 59.196 grams of Si2H3. Now we're going to plug that into our top chart up there with Si2H3. Grams goes on bottom. There we go. There's my pen. Grams goes on bottom to cancel out the grams. And moles goes on top. 1 mole Si2H3. So now we're at moles. When we're in moles, we can do anything. We can go to particles. We can switch substances. Or we can go back to grams. We were already at grams, so we don't want to do that. This question has nothing to do with particles. So we're going to switch substances to our desired one, which is SiO2. To switch substances, you use the mole ratio from the balanced chemical equation, which is up here at the top. And we're looking at Si2H3 and SiO2, which is this one down here. The chemical equation says 4 moles of Si2H3 equals 8 moles of SiO2. And those numbers come straight from the coefficients. We're going to plug that into the chart. Moles of Si2H3 would go on bottom. 4 moles Si2H3 equals 8 moles of SiO2. And now our last step will be to go to grams. For that, we'll need the molar mass chart for SiO2. SiO2 is Si and O, 1 silicon, 2 oxygen. Silicon, we already said, is 28.086 grams. Oxygen is 15.999 grams. Multiply it out to get 28.086 grams and that is 31.998 grams. Add them up, and we're going to get, what's that, 60.084 grams per mole for SiO2. And that is going to become a conversion factor up here. 1 mole of SiO2 equals 60.084 grams of SiO2, which gets used in this conversion up here at the top. Said 1 mole SiO2 is equal to 60.084 grams of SiO2. So now we've taken our 245.1 grams of Si2H3 and made that grams of SiO2. In order to get the correct answer, we need to multiply everything on the top, divide everything on the bottom. I'm going to grab a calculator and do that really quickly. You do the same. And for that answer, I get 497.55 grams SiO2. Now we're going to follow the same process for the bottom reaction, or not the bottom reaction, the bottom reactant here, 152.8 grams of O2, and see how many grams of SiO2 that's going to make. Go ahead, pause the video, try to do this bottom chart for yourself. Once you're done, play the video and we'll see if you got the same thing. All right, you should have gotten 135.02 grams of SiO2 as your final answer there. If you didn't, go back, see what you did wrong, try to figure it out. If you got it right, let's move on. So the real question here is how many grams of SiO2 can be produced with this. So our two reactants were Si2H3 and O2. Using our given amount of Si2H3, we can make almost 500 grams. But with the O2, we would only make 135 and a little bit, and then we would run out. So what's actually physically going to happen in the real world is we're going to use up all of our O2 and have a bunch of Si2H3 left over. So down here, your excess reactant is going to be, let's see, this one up here, Si2H3, that we would have extra of. The one with more is going to be the excess. So we're going to write that down here for excess. That was Si2H3. And for the limiting, it's the other one, the one that we ran out of, O2. The amount that actually gets produced is the amount produced by the limiting, which is down here, 135.02 grams of SiO2. Now for on-level people, this is where you stop. This is as far as you need to know. Don't have to do anything else. Pre-AP people, you do have a little bit extra. You actually need to find out how much Si2H3 is left over. And there are several ways you can do this. So if you have a different valid way to work it, that's totally fine. The way we are going to work this is we're going to go backwards. We're going to say that we're actually making 135.02 grams of SiO2. And we're going to see how much Si2H3 gets used up to make that many grams. So basically, it's like going backwards from what we did before. We're going to go grams of SiO2 back to moles of it using molar mass. So I have 60.084 grams SiO2 becomes 1 mole. Then we're going to switch back to the excess reactant Si2H3. So we need to know how many moles of SiO2 are in the equation and how many moles of Si2H3 are there. So we'll scroll up. We see there's 4 moles of Si2H3 and 8 moles of SiO2. 4 moles of Si2H3, 8 moles of SiO2. So that gets us in moles of SiO2, or sorry, moles of Si2H3. And then we're going to change that to grams using the molar mass we already found. 1 mole of Si2H3 yields or has a molar mass of 59.196 grams. All right, so this conversion tells us how much of the Si2H3 is actually going to be used. Let's do that multiplication and division real quick. All right, and I got 66.5 grams of Si2H3. That's how much was used, okay? And we're trying to find out how much is left over, so we're going to subtract that from our original amount of Si2H3. The original amount was 245.1 grams. So we're going to do 245.1 minus 66.5, which should get you 178.59 grams of Si2H3 is your amount of excess, which is basically just the Si2H3 that you have left over. So if you're in pre-AP, you need to know that extra step for how to find that amount of excess, and it's going to take you a third chart using most of the same conversions you already had from before. All right, guys, hope this was helpful. If you still need help, let us know. Email or pop on to office hours or something. Remember, your test is going to be Monday, so you got to know how to do this stuff fairly quickly. So if you have questions, please let us know.